2.3 polynomial functions. Of higher degree with modeling. So we'll be starting out with looking at how a graph is transformed, and it works the same way as the other ones that we've been doing in other sections. So number 4, g of x is equal to 2/3 times x minus 3 cubed plus 1. So what shifts and things are happening with this one? It's compressed. What else? Right 3. And up 1. 6 g of x is equal to 3 times x minus 1 raised to the 4th minus 2. What is this one? Stretched. It's a number bigger than 1.
I can't remember if it was 0 or 1.
What else?
Right 1 and down 2.
Yep. All right, so we're skipping over a lot of the stuff in this section because it's just like graph this and look at your viewing window and, you know, just y'all know how to graph something, so we don't really need to do that. So the next thing we're going to look at is the end behavior of a polynomial function, which I think I briefly introduced to you last year, probably 2 or 3 problems is all we really did with it. But in case you go on to calculus, it's good to have another kind of touch on that. Basically, we're looking at what happens as x gets really, really big, because we're looking at what happens as x goes to infinity, and what happens as x gets really, really small going to negative infinity. So we always look at the highest powered term when we do that in the sign of the highest powered term, and that helps us to figure it out. So 26, and again, this book only has a couple of them, but I think we'll be able to see what we need to with what they do have. So f of x is equal to negative x cubed plus 7x squared minus 4x plus 3. So always make sure it's in standard form in terms of ordering so that you are actually looking at your highest powered term. And if it's not, you don't need to rewrite it. Just pay attention to the highest powered term and whatever sign is on it. So in this case, my highest term is this negative x cubed. Now, what do you know about a cubic function? What does it look like? Yeah, it kind of does this, right? It goes in opposite directions. Okay, so that means your end behavior should have one thing going toward positive infinity and one thing going toward negative infinity. Okay, they're going to be opposite. Anything that's an odd function is going to be that way. Anything that's an even function is going to be, or well, I should say the highest powered term is even or odd. That's going to tell you what's happening. So in this case, the first thing I'm looking at is the limit as x approaches infinity. So as x gets really, really big, so I always think something like positive 500. What happens if I put in positive 500 for x? And I don't need to know that it's whatever that number would end up being, 125 somethings. I don't need to know that. I just need to know what direction is it going if I put that in. So only pay attention to what's written in yellow, or what's circled in yellow. okay, because it's going in the negative direction. So, of f of x, usually is how we write it, would be going toward negative infinity because of this negative sign out front. And then the limit as x approaches negative infinity of f of x, just save this from having to rewrite the whole function. So if I put in like negative 500, what would be happening? Yeah, it'd be going up because you're still left with a negative when you cube it, and then negative times negative is positive. So this one's going to positive infinity. So anytime your highest power term is odd, it should be going opposite directions. When it's even, they should be going the same direction. So if you didn't get that, go back and check, because most likely something is wrong. Or you've used the wrong term. That would be the only other scenario that could possibly have happened. 28. F of x is equal to x cubed minus x to the fourth plus 3x squared minus 2x plus 7. So what term am I looking at for this one? Negative x to the fourth. So the limit as x approaches infinity of f of x is equal to, so if I put in like positive 500, what is happening?
Negative.
Yeah, negative because this negative sign. The negative is outside of what's getting raised to the fourth. So that one is going to be negative infinity. Then the limit as x approaches negative infinity of f of x. So if I put in negative 500, negative. Because the negative that's on the 500 is getting raised to the fourth power, which is going to become positive. But there's still a negative out front. So, and we want them both to match. And if you're ever like really not sure, throw it in your calculator, because your calculator is going to show you which direction it's going. So I would say obviously try to do the problem without typing it in, but if you're like, I don't know if I did this right or whatever, you just want to check and be like, hey, I put that it's going to negative infinity, and then you put it in, and all of a sudden it's supposed to be going to positive infinity, you'll realize, oh, I did something wrong. Because the graph obviously is the foolproof method to make sure that you do it right. Yeah, just pick a big number. Okay. I mean, it doesn't really matter, but obviously it says x goes to infinity, so that's why I say pick a really big number. I mean, with these, it's not that big of a deal, but when you get to something like when it's like fractions, that can be where you need to be careful. So I just always train you to use something like 500, so that when you get to calculus and you're dealing with like numbers over numbers, that you know what you're looking for. But basically, what happens is it goes way out there and way out there is what I care about. So, slightly different use of that poem, but I just realized I don't think I've graded your test. Nice something to do later now. I was sitting there the last 2 class periods trying to find things to do, so I've been writing tests and quizzes for the next like week, and could have just done that. All right, 34. These say to find the zeros of the function algebraically. So basically, we're going to be factoring and setting it equal to 0 and solving. So f of x is equal to 3x squared plus 4x minus 4. So how would I factor this? Yep, and what would those be?
Positive 6 and negative 2.
Yep. So 3x squared plus 6x minus 2x minus 4. So then, and ultimately this is going to be equal to 0, so take out a 3x, so that leaves you with x plus 2, take out a negative 2, x plus 2, so I've got 3x minus 2 times x plus 2, and then you just need to split them. 3x minus 2 equals 0, x plus 2 equals 0. So then we get x is equal to 2/3 and x is equal to negative 2. Or I guess technically it's or. And so those would be the zeros. And if you're ever not sure that you did this right, especially when we get to ones that are bigger, you can always do like graph them to check them. Now they say you have to do them algebraically, but if you get to the AP exam and it's a multiple choice question and they say find the zeros, you can do it on your calculator and use the second trace, which is calculate, and find the zeros like we did I think we did zeros a couple weeks ago. I don't know. But the same way you find where it'll be like left bound, right bound, you could find the zeros that way also to verify. So that would be an option. All right. 36. F of x is equal to x cubed minus 25x. What would I need to do with this one?
So you can take out an x.
Take out an x first, so this is going to give me x times x squared minus 25.
And
Now
that's
what?
the difference of squares.
Yep. So, which factors into what?
X minus 5 and x plus 5.
Yep. And so then set it equal to 0 and solve. So x equals 0, x minus 5 equals 0, x plus 5 equals 0. So then x equals 5, x equals negative 5. Are you okay with that? I feel like a lot of this is stuff you've done before. It's just looking at it a little differently.
Yeah.
All right, these next ones, again, it's similar to what we've done before, but now we're adding on the multiplicity aspect of it. And so basically it says state the degree, list the zeros of the polynomial function, then state the multiplicity of each zero. And it asks some other questions after that, but that's the key important stuff that we're going to do. And so they give us a function like 40, f of x is equal to negative x cubed times x minus 2. And so when we're looking at degree, okay, the tendency of this problem is for you to tell me that it is degree 3 because that's the highest power that you see. But do you know why that would be wrong?
Because there's an x in the parentheses and we took out the x to the third.
Yes, so we need to multiply that back through. Okay, if it was all being added, then it would be x cubed. But because it's being multiplied, we need to multiply all the x's through. So this will actually be degree what? So it would be a degree 4. X cubed times x gives you x to the 4th. Or well, negative x to the 4th. Anyways. So then I want my zeros. So basically if I set this equal to 0, what would my zeros be?
0 and 2.
Yep. Zeros, we would have an x equals 0 and an x equals 2. And then the last thing we want is the multiplicity of each 0, which just means how many times does each of those occur. And so the easy one is the x equals 2. there's only one of those, okay, because it's just raised to the first power. So this one is going to be a multiplicity of 1. But x equals 0, how many times or how many x's do we have that that's happening for? 3. So this is going to be multiplicity 3. Because we should have just as many zeros as is the degree of our function. And so before when we did these, when we would have degree whatever, I would just say what are the zeros? And we wouldn't always have the same amount of zeros as was our degree because we hadn't learned multiplicity yet. So now 3 zeros occur at 0 and 1 0 occurs at 2, which gives us our 4 zeros that make up degree 4. Now, when we get to irrational problems or things that have i's in them, it changes a little bit. But we're not there yet. So right now, you should still have the amount that is required. Let's see, 42. F of x is equal to 7 times x minus 3 squared times x plus 5 raised to the 4th. So again, the first thing I'm looking for is the degree of the function. Any idea what the degree of this function is? 6. How'd you get that?
So we have one thing that has an x term that's squared, and then we have another that's to the 4th, and we are multiplying those, so then we have x to the 6th.
Yep. So the thing that I'm just going to remind you is that obviously x minus 3 squared is not x squared minus 3 squared. Okay, it's x minus 3 times x minus 3. Just don't forget that. But what he said is exactly right. All we need to do, the most we can have in this first parentheses here is x squared, right? There's no way I can get anything more than that. And then over here, the most I can get is x to the 4th. And then when you multiply that all together, you get that. Just don't get confused and be like, well, it's just x to the 4th plus 5 to the 4th. Like, no. Don't go back to that math. Not accurate math. I still have people do that. Not y'all, but people do that still. I'm like, no, that's not math. Anyways. So yeah, so this is a degree 6. So then my zeros would be what? -5, yep, that'd be one of them. What else?
X equals 3.
Yep. Now what about that 7 that's out front?
That's just a stretch.
Yes. It's just irrelevant. There's no x there. If there was an x there, then obviously we would have an x equals 0 again. But that 7, when it's set equal to 0, just disappears. So it was a trick question.
So if we had an x on that 7, then would this be a degree 7?
Yes. If it was a 7x or even just a x, it would be a degree 7 instead. So then now multiplicity, and I'm just going to shorten it to mult. I don't want to write out multiplicity every time. So how many times do we have a 0 at x equals -5?
4.
4 times. And how about at x equals 3? 2.
So is it, we're just going off the exponent?
Yep. You could have x to the 100th, and it would occur 100 times. Now, that would be awful, but you could. Yeah, all that exponent is telling you how many times it's happening.
I mean, as long as it's the same 0, I guess I'd be okay with it.
All right, so we have done finding zeros by basically factoring. And so we get a function and we find what the zeros are. The next set of problems is they give you the zeros, you need to find the function. So it's working backwards, basically. So, and there's another set of problems in between that has find the zeros of the function either algebraically or graphically. So you can choose whichever method, but since we already did that up here, I'm not going to do another one, but just know that that's why there's one from in that section. We may actually do one of them on the calculator in a minute, but to start with, we're going to do the ones where we're working backwards. So 54. So they give us the zeros -2, 3, and -5. So based on that, what type of function am I going to have?
Cubic.
A cubic function. Now it actually tells you that in the instructions, but I just want to see if you're paying attention.
Well, at least it should be cubic.
Yeah. So notice these are zeros, which means that this is x equals -2, x equals 3, and x equals -5. So that means to get my factors that I'm going to be multiplying, I need to move those numbers over. So the signs on them are going to change. So you can either know when I'm given zeros, I change the sign to get my parentheses pairings or whatever, or you need to set it up like this and move it. When we get to the ones that do have imaginary numbers in them, you're probably going to want to set them up this way because they get a little more complicated. So x plus 2 is a factor, x minus 3 is a factor, and x plus 5 is a factor. Slide this one over. So then now I just simply need to superfoil and get my answer. So x squared minus 3x plus 2x, so minus x minus 6 times x plus 5. So I get x cubed plus 5x squared minus x squared minus 5x minus 6x minus 30. So x cubed plus 4x squared minus 11x minus 30 would be what gets you to that. Now, I'm going to point something out about 56 just because it will lead into the stuff that we'll do. I don't know if it's actually in this chapter or if it's later, but we have the zeros 1 plus the square root of 2, and 1 minus the square root of 2. Anytime you have a square root, they may not give you all the zeros. Okay, if you have a square root or an imaginary number, if we have the plus whatever the square root is, we also have to have the minus whatever the square root is, okay, because of the plus or minus thing. It works the same way with i's. So they've already told us this is a cubic function. They've already given me both zeros, but when we get to the stuff later in the book, they will only give you one of them, and you have to remember I need to write the other one. So just be aware of that. But this is, again, one of the problems where I say you need to probably write them like I did up here as x equals whatever because of moving things over. And I say that only because I've seen people mix up the signs a lot when it's stuff like this as a 0. So you would have this as x is equal to 1. That one, you could probably get regardless. But x equals 1 plus the square root of 2, and x equals 1 minus the square root of 2. Because then my factors that I'm multiplying become x minus 1. This becomes x minus 1 minus the square root of 2. And then this one becomes x minus 1 plus the square root of 2. And so people just get the signs wrong with that a lot, which is why I try to train your brain this way from the beginning so that you don't get confused when you do this. But yeah, anyways, I'm not going to actually multiply that one through. But you can if you get ambitious later. The other thing I will point out, the book may or may not do it. Some books will put in front of the factors, they may write a K or something as a constant value, just because you don't know that there's not a number in front of your x cubed term that's getting multiplied through. But this book doesn't appear to write it. Some books do. So if you ever see, like, let's say you get to the AP exam and there's a random constant in front, that's why. Basically just more informational for you at that point. I'm going to go back and just show you on your calculator about how to get the zeros of something that maybe you don't know how to factor, that we need to do graphically. So I'm going to put up 52. So get out your calculators and type this problem into it. F of x is equal to x cubed minus 4x squared minus 44x plus 96. And so these are the problems that can be done either algebraically or graphically. So we're going to do this one graphically. Once I find my calculator. Found it. Under all the trash. If you for some reason have a scatter plot on, Josh, you might want to turn it off before you do this if you didn't already.
This thing looks like it's having good fun.
So I'm going to have 3 zeros with this one. Okay, so the graph, obviously, when you do Zoom 6, you can't see the entire graph on your screen because, well, it's really big, to be quite frank. So all I care about, though, is where it crosses the x-axis. That's my zeros that I'm looking for. And so all I need to do is be able to see this part of the graph right in here is what I can see here on the axis. So if you hit second trace, that brings up calc. Option 2 is zeros, so that's what we need.
What's the rest of the function under the calculator?
It's 44x plus 96. The glare on it makes it like weird to see.
Yeah, after that I just press.
And Zoom 6.
Oh.
Now I'm trying to find, where is my thingy? Hello? 2, 3, 4, 5, 6. Oh, there it is. Nope, come back. Where'd it go? Okay, left bound, it's weird because I guess the function, is it negative? No, it's positive.
No, it's just really big.
Alright, so left bound on this one is weird. It's actually below. Okay, so I can't even see mine, but it's down here somewhere. So hit enter, then arrow up above the x-axis, and hit enter again. And then it'll guess. And so there's a 0 at -6 for this one. So x equals -6 is one of them. Were y'all able to get that one?
I can get my dot to move off the line closest to the y-axis.
What do you mean?
like whenever I move it, the thing up and down doesn't. Huh?
Can I see it?
You're probably just gonna have to. Well, you need to use the left and right arrows, I think.
Well, I did, but then it would just like go up and down, and it was like moving by a lot. It's like I was only able to move it one, and then I wouldn't be able to see it anymore.
You'll probably just have to run it
Yeah,
over
big.
until you get over because the graph is really big.
Okay.
Yeah.
That's why I was literally just holding it until I got it to come up a minute
Okay.
ago.
Also, what happened to your other calculator?
It's dead.
I was gonna ask if you let it die.
Yes. Well.
Well,
Yeah.
okay, so you just need to press left like one more time there. Then you press enter. Then you press right a few times.
And we need to do the same thing to get the other one. So, or, well, we have two more. So second trace, 0. And so this one, as you arrow to the right, this one is going to end up being above the x-axis is your left, because as I arrowed to the right, this graph started here, went up, came down, and then it's going to go up again. So on this side, my left is up above the x-axis. Oops, went too far. Right is over here below the x-axis, and let it guess again. And so I've got another 0 at x equals 2. And then on the last one, your left is going to be below and your right is going to be above, just because of how the graph goes. So whoa, I went too far. Come back. No, where'd you go?
Maybe you want to play hide and seek.
Apparently so.
Unload.
And then the last one is at x equals 8. So if you're like, well, how did I know which way the graph started or whatever? One, as you arrow over, it's going to show you, and it shows you the x and y values on the bottom, so you can see if x is getting bigger or smaller, and that will tell you. But also, when you initially hit zoom 6 after you graph it, it actually traces the graph for you, so you can see it that way. And that will tell you which way it goes to kind of help you. Any questions about this stuff? All right, problems then are 3, 5, 25, 27, 33, 35, 39, 41, 49, and 53. If you want one like 52 to try, I would say like to try on your own 51, but you don't have to do that one. That one's just going to be like 52 if you want to try something like that.